So local behavior is more what's happening in between the ends. So when asked to describe the local behavior of a function, we're looking at the middle of the graph and determining where the graph changes behavior. Particularly, we're finding the intercepts. Those are important points. And turning points. So what's a turning point? A turning point, or what's called a local max or min, is the point where a graph changes from increase to decrease or vice versa. So for example, if we have a polynomial that's doing this, this is a turning point, this is a turning point. You can consider it like those inside vertexes, a local max or min. Now, a polynomial whose highest exponent is n other words, has a degree n, has at most n zeros and n minus 1, put that parentheses, n minus 1 turning points. If you forget that little piece of information, think of x squared, okay? So our n is 2. So for any parabola, you will have at most 2 x-intercepts or zeros and 1 turning point. Now again, it means at most because that parabola could have no zeros. The whole parabola can be above the x-axis and never touch it. Okay, so it's at most n zeros and 1 less than that turning point. So here's a couple of things that you guys can practice on your own. If you want to pause it and give these a shot, otherwise we can do them together. You want to draw an even degree polynomial with 4 zeros and 3 turning points. So remember, an even degree has to eventually be facing the same direction. Either the ends all go up or the ends all go down. So if we need 4 zeros, there's 1 x-intercept, 2 x-intercepts, 3 x-intercepts, 4 x-intercepts. Okay, and it's even, it's going in the same direction. So there's our 4 zeros with 3 turning points. 3 turning points and 4 zeros. Next example to the right, we want to draw an odd degree polynomial with 3 zeros and 4 turning points. So remember, 3 zeros, 1, 2, 3. So that looks like an odd polynomial with 3 zeros. But right now, it only has 2 turning points. So we need 4 turning points without it crossing the x-axis again. We can do that. 1, 2. So now it has 2 more turning points without adding any zeros. But it's still an odd because it's going in 2 different directions with the end behavior. Now let's see if we can draw an even degree polynomial with no zeros and 3 turning points. No zeros just means it never crosses the x-axis. So we need the entire thing below or the entire thing above. We need 3 turning points. So there's 1, 2, 3. 3 turning points. But no x-intercepts, no zeros. Now let's draw an odd graph with 2 zeros and 2 turning points. This can be tricky. What this means is one of those zeros is going to just touch the x-axis. So here's 2 zeros, but one of those zeros is also a turning point. 2 zeros and 2 turning points. So remember, an intercept is where it crosses or touches an axis. It could just touch it and bounce right off. So let's take a look at these graphs and see what degree they possibly could be. For example, we know this graph in the top left has to be even. It has 1, 2, 3, 4 x-intercepts. So it could be of degree 4. Matter of fact, that is the smallest degree that it could be. Because remember, it could have at most n zeros. For this next example, we have 3 zeros, but 4 turning points. So if there are 4 turning points, remember our turning points have n-1 turning points. So this would be a smallest degree would be 5. This bottom left has 3 turning points and it's even. So its smallest degree would be 4. And this is an odd graph with 2 zeros and 2 turning points. So we have a smallest degree is 3.